Hey guys, welcome back to SPOTO channel. I'm the CCI tutor from SPOTO, and this channel is created by SPOTO to share about the latest news on network, project management, and cybersecurity news, trends, and exam tips. I really appreciate if you can subscribe our channel and give me a thumb up to the video, which allows my video reach out to more people just like you. So today our focus is on the data analysis of EI-lab topology. This is the complete EI-lab topology diagram, which mainly examines the candidate's deploy, operate, and optimize capabilities, referred to as DOO, which is mainly configured from routing and switching, and SDA and SD1, and programming. This belongs to the HQ category, and this module belongs to the DC category, and the module on the right belongs to the IaaS, and the SP1 and SP2 are connected, and the corresponding four branches are belongs to the HP. So among them, this module is mainly the routing and switching part, which first realize the whole network communication, and this module is mainly examines the SDA and SD1 technology, and mainly manages and configure the equipment of the local area network and wide area network in a unified manner. And the right part is our programming. Programming is relatively simple for SPOTO students. So this is the complete routing and switching module, which requires us to accurately ensure that the phenomenon of each requirement can occur normally. If there is a problem with the routing and switching part, it will directly affect the SDN module. Routing and switching mainly assess candidates through artificial configuration and multiple choice questions. So today we mainly explain the relevant knowledge points and their application in EI lab. So, in the scope of HQ category, the main technologies are involved are Ether channel and spanning tree, OSPF, VRRP, DHCP, EIGRP, and extend-on. So, in EI lab, the spanning tree technologies involved are RPVST and MRST. RPVST and MRST. Today we will introduce the related technologies and principles of RSTP in EI lab. So there are 5 types of spanning tree, among which PVST and PVST Plus are belong to Cisco protocols, and 802.1d and 802.13 and 802.1s belong to are public protocols. So, first of all, there are 5 states. There are 5 states in STP, including disable, blocking, listening, learning, and forwarding. The state specification of RSTP is reduced to 3 types, which are divided according to whether the port forward user traffic and length MAC address. So it includes discarding, learning, and forwarding. And the port rows of RSTP are root port. Wait a moment. So the port row of RSTP are root port RP and design port GP and alternate AP and backup port BP. So from the configuration of sending BPDU, alternate port is a port that is blocked due to learning configuration BPDUs sent by other bridges, and a backup port is a port that is blocked due to learning the configuration BPDU sent it by itself. And from the user traffic analysis, alternate port provide another switchable path from the design bridge to the root as an alternate port for the root port. If the root port is destroyed, the switch can through alternate port to the root bridge. And a backup of the design port, it provides another backup path from the root bridge to the corresponding network segment. And the port fast enable the layer 2 interface to immediately enter the forwarding state. Port fast can only be used on the access port. The port can drop directly from the blocking state to the forwarding state without going through the listening and learning state. At the same time, it can suppress the topology change notification. So the port fast used to connect the PC or serve. And in RSTP, the core knowledge point is PA negotiation. PA is very important knowledge point to make a root port, RP, and design port enter the forwarding state as soon as possible. First, when the link is enabled, both root and switch A are received BPDU sent to each other. Switch A receives a beta BPDUs and the port 1 becomes to the root port. At the same time, it knows that the port 0 is the design port and start to PA mechanism. Second, P0 of root send a proposal to port 1 of switch A, and port 2 and port 4 of A are blocked, and edge port which directly reach the synchronization state. And port 3 is design port which will be blocked and reach the synchronization state. Then, after the synchronization is complete, switch A sends agreement to the root to inform. Finally, after the root is received, P0 turns to forwarding state. At this time, port 3 continue to be blocked and switch A continue to initiate proposal to B from the specified interface. PA procedures are very fast because they are not limited by any times. The handshake mechanism quickly spreads to the end of the entire switching network and can quickly coverage when topology changes. But if a designated discarding interface doesn't receive an agreement after sending a proposal, for example, the switch C, the port is design port, and switch B, this port is blocking port. So when this port send proposal, this port can't reply agreement. So it will slowly transmission to the forwarding state, which is the traditional listen, and learning and forwarding procedure of the 802.1d. This situation may occur when the peer switch doesn't understand the RSTP BPDOs or the port of the peer switch is blocked. So regarding the change of topology change mechanism in STP, when the root bridge is selected, the non-root bridge itself doesn't generate its own BPDO, but in RSTP, each switches in STP can automatically generate and send BPDOs, regardless of whether it receives a BPDO from the root bridge. It sends its own BPDO configuration information every hello time. The default time is 2 seconds. And when the bridge doesn't receive BPDOs for 3 consecutive times, the bridge considers that the neighbor root and the design root have been lost and immediately edges its BPDO configuration information. And when the network topology changes, the switch sends TC BPDO to all ports except the edge port, and at the same time clears the landmark address on the all port except edge port on the switch, and then sends the TC BPDO to other switches. So in this way, RSTP can quickly spread the topology change notification to the entire network, thus achieving fast convergence. And only when the non-edge port goes from blocking state to forwarding state will cause topology change. Unlike 802.1d, connection loss doesn't cause topology change. In other words, if a state enters the blocking state, it won't cause the corresponding bridge to generate the TC BPDO. And the RPVST plus it generates spanning tree instance for each VLAN. It needs to carry the VLAN ID information through the BID field. Use the extension system ID and bridge ID contains the bridge priority and MAC address. So finally, let's look at the configuration command. The first command is used to specify the spanning tree mode, and the both command can be used to modify the priority of the switch. If you want to use this command, spanning tree VLAN ID priority, when you use this command, when modifying the priority of the switch, it must be a multiple of 4096, which is related to the VLAN ID. So if you use this command, spanning tree VLAN ID root primary or root secondary, it means that primary means that the priority of the specified switch is priority 0, and the secondary refers to the priority of modification level is 4096. So, these commands are used to configure the port fast. We can configure the port fast under interface or configure it in a global. Okay, so and these commands are to view the spanning tree. So let's demonstrate the configure together. Let's first introduce the RSTP requirement in EILab. First of all, there are two VLAN ID in this HQ category. It includes VLAN 2000 and VLAN 2001, and the EILab requires us the STP root of VLAN 2000 must be switch 101, and STP root of VLAN 2001 must be switch 102, and we must prevent the access interface from participating in the PA negotiation process. So, this requirement, we should use the port fast to solve it. So, let's demonstrate the configuration together.